The modern multi-domain operational environment is a tightly woven network of dependencies. A strain on logistics pathways instantly translates into friction across electronic warfare, cyber, and physical space until the connections collapse entirely. Conventional command and control analytics, even advanced sensor fusion engines, operate on a reactive delay. They monitor individual domains and wait to measure what has already happened. While these systems deliver high-fidelity alerts, they trigger only after an operational disruption has escalated enough to become physically observable to a sensor. Relying exclusively on observable failure alerts guarantees that a commander will always be forced to react to the adversary's timeline, ceding decision dominance. MIT graduate and Future Logic Architecture Systems founder Dr. Curtis Charles designed a framework to solve the specific delay. Strike AI is a decision intelligence layer that sits strictly above the sensor and C2 technologies currently operating in the field. The system computes what is actively forming from what those sensors are seeing, rather than waiting for discrete, isolated events to surface. Over the next few minutes, we will deconstruct the mathematics and architecture of Strike AI, proving how it calculates hidden vulnerabilities across multi-domain operations. By shifting from sensor-driven observation to mathematical anticipation, this architecture provides commanders with the exact quantified time window required to act before a failure occurs. The entire system is anchored by a core metric, the first law of governability. Look closely at this equation. The denominator, Chi-F, is convergence pressure. Convergence pressure measures the hidden synchronization of interdependent risks forming across different data streams, like ISR, space, and communications. Above it sits the numerator, omega F, which represents decision space. Decision space quantifies remaining intervention capacity and alternate options available to the commander. As operational friction increases, the capacity to act inversely shrinks. Tracking this ratio signals approaching vulnerability before the system physically breaks. Strike AI operates as a software intelligence layer, passively ingesting data streams through standard application programming interfaces. It consumes structured and unstructured inputs, unclassified AIS shipping data, GTM logistics and ISR video feeds, electronic warfare, and raw network telemetry. Domain I, situational formation, translates this raw data into the structure you see here, the freight and force dynamic multi-layer dependency graph. It's a real-time map tracking how a delay in logistics mathematically connects to a degradation in communications. Without mapping these cross-domain dependencies, isolated sensors would never detect the compounding structural stress until a catastrophic failure forced a visible alert. With the map constructed, the data routes to Domain 2, structure discovery. Here, the analytical engine scans the FDM-DG graph. This processing power comes from the AI-squared framework. Because standard machine learning relies entirely on historical pattern matching, it produces brittle, binary alerts when placed into novel, highly contested environments. This chart details the solution. On the left, a standard machine learning alert spikes abruptly to 100%. On the right, the AI-squared framework combines machine learning with actuarial accumulation of risk methodologies to generate a widening cone of quantified probability. This actuarial approach calculates the precise heat and tension accumulating on specific clusters within the network, even if the model has never encountered that exact operational scenario before. It operates like monitoring a system stretching to its absolute physical limits, silently absorbing pressure right before the breaking point. By utilizing actuarial mathematics rather than simple pattern matching, the engine delivers continuous, bounded estimates of structural pressure instead of reactive black box binary warnings. This processing delivers the final mathematical output, the zero-day decision window. This window formalizes the gap between T sigma, when structural convergence emerges, and TO, when an observable failure triggers alerts. In the Indo-Pacific Sea Lift benchmark, the Chi pressure line peaked at 0.92 at T sigma, driving available decision space down to 0.31. The system accurately identified a critical multi-domain logistics strain 86 hours before conventional sensors would have registered a single anomaly. Because the underlying graph architecture is domain agnostic, these lead times persist across different operational theaters. In a global fuel logistics stress test, the system identified structural convergence 104 hours before disruption. Securing an 86-hour window grants the commander the exact, quantified lead time required to preempt a disruption, rather than scrambling to mitigate the damage. Translating this structural mathematics into operational commands occurs in Domain 3, Governability Preservation, seen here as the top of this 13-layer stack. Layer 12 is the Executive Decision Interface, which delivers these machine speed recommendations directly to human decision-makers. It preserves full human operator authority, ensuring automated analysis is always subject to command override. To maintain these outputs in contested environments, Layer 2 provides fault-tolerant stability. In denied, disrupted, intermittent, or limited environments, core structural estimates can run locally. Once the multi-layer map is initialized, the system does not require external connectivity to function. This ensures anticipatory intelligence survives direct contact with an adversary's electronic warfare and cyber degradation efforts. Strike AIG is a software-only deployment requiring no new physical hardware. It operates passively, introduces zero new emissions, and requires no modifications to existing command and control systems. Phase 2 integration pathways include tactical awareness plugin deployments and overlays for live, virtual, and constructive environments. The system functions as a structural intelligence layer above existing sensor and C2 outputs, providing the necessary window for operators to effectively employ their remaining tactical assets. By identifying vulnerability before it becomes observable, Strike AIG provides commanders with the one multi-domain resource they cannot manufacture: time.